Hi everyone, welcome to PATalks 45, and we are super excited to continue this series, and we have today a very super special guest joining us from United States. He is Robert McNeel. He's the CEO, founder of Robert McNeel and Associates, and the company behind one of the most famous software for designers, which is called Rhinoceros 3D. Robert McNeel and Associates is an American privately held employee-owned company founded in 1980. Rhinoceros, their most used product, is based on the NURBS mathematical model, which focuses on the producing of mathematically precise representation of curves and freeform surfaces in computer environment. Today, Rhino, together with Grasshopper 3D, is among the most used software in architecture and design industry. I'm sure you all have used this software and you know about their capabilities. And before starting this episode, I want to thank you, Shapediver, for sponsoring this video. Shapediver is the leading platform for hosting and publishing Grasshopper files on the cloud. Easily create web applications based on your Grasshopper files and share them with coworkers or even your clients around the world. You can visit shapediver.com and create a free account today. So if you guys are ready, please join me for this insightful conversation with Robert McNeel. Robert, would you please talk a little bit about yourself and discuss your background?
Well, I guess it depends on how much time you have, but my background, I guess, is pretty simple in that I graduated from high school in 1968 and wandered around a bit, doing odd jobs, spent some time in the Army, eventually finished college with an accounting degree and went to work in public accounting. I did that for a few years, was pretty frustrated with the tools that we had. Back in those days, computers were timeshare, microprocessor-based computers weren't really available. They had just begun to show up. Anyway, I ended up starting to write accounting software for a micro-based computer, helping other people with their computers, which included the architecture firm that my wife worked for. One thing led to another, and pretty soon we were supporting and selling AutoCAD and writing software tools, basically macro sets on top of AutoCAD to help out people that were trying to get their drafting done more efficiently. That eventually led to more complex tools, which included adding some spline-based technology to AutoCAD, primarily for our marine clients. That was very awkward to do in AutoCAD, so we ended up making a little Windows application. Our idea was it was just going to be a utility program that ran alongside. The market size was fairly small, maybe 500,000 users total worldwide. But as soon as we put it out there, first as a prototype, at that point the internet stuff was starting to work, so we just shared it with a few people that were interested, and it sort of took on a life of its own in terms of what people were asking for, and so we just kept adding to it, and 10 years after that we were making our living completely on Rhino. Pretty much how we got where we are. We never have done anything really special other than try to help people do whatever they ask us to. I guess the thing that's not really obvious to most people is my background's not in architecture, computer science, or design. It's basically business. So
yeah, nice. Can you also discuss how did the idea of Rhino software came along, and what was the reason to choose the Rhino as the name of the software?
Yeah, the software, like I mentioned, really the beginning of it was trying to help out some of our marine clients. And it was sort of a timing thing in that many of the shipyards at that point were starting to get some computer-controlled plasma cutters for cutting out steel. At that time, everybody was using AutoCAD for drawing and drafting, and AutoCAD at that time only had lines and arcs. They needed smooth curves in order to drive these machines properly. And so we teamed up with some programmers that had left Boeing, had worked in R&D at Boeing to figure out the math. And we just added basically initially 2D splines to AutoCAD. And that's what drove it. Of course, as soon as we had 2D splines, and they wanted 3D spline curves, and then they wanted 3D spline surfaces, it just kind of went on and on from there as far as the core geometry. The important thing, I guess, to keep in mind was that everything we've done since then is really driven by the assumption that the end use for the geometry is going to be to drive digital processes. So everything it needs to have the precision and the accuracy to drive manufacturable or digital manufacturing systems. So that's really core to what we do. Every time we do anything, we have to sort of loop back around that and say, how's this going to go downstream to the fabrication process? Of course, there's lots of steps in between, whether it's, just doing drawings or renderings or, all kinds of analysis, either for design or, design validation, or some more sophisticated things like, CFD or whatever. So we have to generate geometry that's compatible in some form with those downstream processes.
Right. So you had a team of developers who helped you to build this software and work on the technical parts of it. I remember you mentioned you are mostly at the business side of the company and you're not dealing with the engineering part, with the coding and developing part. So can you tell us how does that work for you?
Well, initially, initially it was just me and one of my college roommates. His background was architecture, and mostly what we did initially was just add. In those days, the programming environment for AutoCAD was Lisp, and so it was basically just adding a bunch of Lisp macros to AutoCAD. And that's where we started. We didn't get into any real programming until we started adding splines to and that's when we teamed up with this other group that in Seattle that they actually supplied consulting services and libraries, math libraries, to a number of other companies. So we teamed up with them to essentially we licensed their work. Eventually, the company was purchased by Autodesk, and at that time it was actually Alias up in Canada. We ended up hiring the programmers that didn't want to move and mathematicians that didn't want to move to Canada or didn't want to move. So they just became part of our team. By the time we really got serious about this, it was pretty obvious that, this was code that was written in a research lab at Boeing originally. And so it wasn't really commercially robust. And so we ended up rewriting it from scratch shortly after the Alias had acquired this little company. That took a couple years, and then since then, of course, we've added more real programmers, more mathematicians to the team that specialize in geometry.
So with that work, when was the first version initially released with the new name, or probably with the name of Rhino? Not as the extension for AutoCAD, but the new software. When was it exactly?
Yeah, boy, I guess I'd have to look that up. It was in the mid-90s. Somebody put a wiki page together somewhere with all of that stuff listed on it. We sort of started the project in May of 1992. Actually released the first version of it in 98. Yeah, I mean, the first versions of it, of course, were in AutoCAD. So we spent quite a bit of time trying to do this in AutoCAD. And it looks like we started the standalone Windows version in about 94. Yeah, it was really driven by the fact that initially we'd started this project as a 2D spline project, which worked just fine in AutoCAD. But once the customer base wanted 3D splines and 3D surfaces, AutoCAD wasn't 3D at that time, or if it was very limited. So once we moved to Windows, then we could manipulate the view in 3D and figure out how to select things and highlight things and, show things on the screen in a way that made sense that we couldn't do very well inside AutoCAD at that time. It probably would be possible or even easy to do in AutoCAD now, but that's what motivated the Windows. But once it was, once we had the Windows version out there were a lot of people that weren't AutoCAD users that weren't interested in it for other reasons, for other applications. And, there are lots of things that require freeform shapes that can be manufactured. So, it just sort of took off on its own from there. Probably some of the early big ones were things like jewelry, footwear, and of course industrial design. Not so much the mechanics of things or anything like that, but the bits and pieces that you can see or touch.
What about the first version of the product? Was it just to respond to the needs of the current clients or the demands of current clients, or were you thinking of in much more bigger scale to work with architects, designers, engineers? How was that scale that you framed it out?
Yeah, well, we released the pre-release. We had pre-release versions of them. We've always done our development, I guess, in public, in the sense that anybody could download the build of the day. And so by the time we released the first version, there were about 100,000 users of the pre-release version. Yeah, of course it was free, so once we released it, not that many bought it, but it was still, it had a life of its own out there and, found all kinds of different markets. So, but fundamentally it was all still driven by the same idea of high precision, freeform modeling tools. And we always assumed that it was a utility. It's not designed, or was our intent really has never been for it to be somebody's single core tool in their tool chain. We always have to fit into the tool set in whatever way makes sense for people's workflow. And probably the other key part of it was because of our experience with AutoCAD, which is a very generic product, it didn't really work very well for anybody unless you added some macros or whatever to it. So even from the very earliest versions, we made sure that there was a macro language, it was extensible. I think there was a command line macros originally, which I guess is still there. And then there were things like Visual Basic that people could use to build more complex things. And, we were pretty aware, and still are, that we don't know very much about each individual market where people use Rhino. So we had to make it easy for other people that did know something about whatever it was, the jewelry industry, for example, or footwear industry, to build on top of it. And so it's always had some kind of way to, or it's always been sort of a development platform as well as a tool.
How did you choose the name Rhino for the software?
Quite a mistake, actually. The lucky mistake, I guess, in that we had a name picked out for it, and just before we got ready to release it, we found out we had some trademark problems with the name. The person that had started the Windows version of it, when you start a new development project, you've got to set up a directory where you're going to store all your source files and all that. And he just happened to have a poster he had all these posters he'd printed out and pasted on his wall. And one of them was the Dur woodcut, which is sort of a famous sort of line drawing of a rhinoceros that he had on his wall. And he just happened to name the directory Rhinoceros when he started the project. So by the time we got close to release, a lot of the pre-release users, the beta users, knew that that's what it was called. So when we ran into trademark problems, it was just like, well, why are you going to change the name? Everybody calls it Rhino anyway. And there's a lot of issues related to that. One is, you got to find a name that works worldwide, that doesn't, people don't have a different word for it. People can pronounce it, people can spell it. You could get a website for it. You don't have trademark problems, on and on. Once we started exploring that and found out it actually worked, I think Russian's the only language we could find where they actually have a different name for it. Every other language essentially is some very close derivative of Rhinoceros.
Yeah, actually that opened the floodgates for other animal names to come to Rhino and Grasshopper. A lot of them, ladybug, heteropotra, and other names.
I think it translates to English as horned cow, as the two words they've concatenated together in Russian to mean rhinoceros or something like that. I don't really know, but that's somebody told me that story. Yeah, and now it's a marketing problem, right? So you need some coherence in how things are named and what people expect. And at that time, all of those 3D products were coming along, and you can spell almost all of them by concatenating together 2 or 3 or 4 words, of which solids is usually one of them, or surface or something like that. And so if it would have been really easy to get lost in that blur of names that everybody uses.
Right, I can imagine. Actually, the company joined forces around 2007 and 2008 to add a visual scripting feature to the Rhino software. And can you talk about the inspiration behind adding this visual scripting feature to the Rhino, which is called Grasshopper, but back then it was called at first, I think, Explicit History. And where was the idea come from?
Sure. Well, it really wasn't our idea. That type of visual scripting language has been around for a long time. And in the AEC space, which is where we were focused with it primarily, was generative components, which you may be familiar with. Robert Ash's product originally, or project originally, I think it was a research project. And we were talking to him about doing something in Rhino early on, and he was pretty interested, but then sort of disappeared. I mean, we didn't hear from him for a while, and then he showed up at Bentley, and the project sort of wandered off over there. And so at that point it was like, okay, what are we going to do about this? So David prototyped something over the Christmas holiday, and we sort of took a look at it and said, well, that might solve the problem. So, I mean, the basic problem was that in most of the industries that we're in, the projects and products are pretty consistent. I mean, in the sense that, the way shoes are manufactured, they are designed and manufactured, is a process that people set up, and everybody in the industry basically does the same process. And so you can build tools that just fit into that process. But once you move into the AC space, essentially every project is a prototype. Even the process is almost prototype, depending on what the building type is. I mean, sure, there are people that may be specialized in sort of medical office buildings, right, that just have it down to a routine. But especially if there's freeform involved in the architecture, that it's hard to say how that thing's going to get designed, manufactured, engineered, assembled, blah, blah, blah. So early on, we were getting a lot of requests for people wanting to learn. And I think, if I remember right, the primary language that we were using then was Python. probably. And of course, architectural designers and engineers, the engineers sort of would adopt it pretty quickly. The architects thought it was tedious and boring. And we'd have classes and you'd have whatever, 20 people show up, and you could tell that only, maybe 3 or 4 people would actually be able to ever produce anything useful. And so when, as we watched, the GC project and other projects like that, they're ones for programming control systems and all that kind of stuff that work similarly. It seemed like an obvious solution. And so, once it started rolling out, it kind of got adopted fairly quickly. Then we kept it sort of as a separate project because the development cycle was faster than the Rhino itself. So we could release new versions of it, weekly without somebody having to update their Rhino. And that made it possible to develop it much faster. And now, of course, it's integrated and ships with Rhinos and gets, it gets updates, but not a lot with every build of Rhino. And the, Grasshopper 2 is a separate development project, which, hasn't shown up in public yet, but hopefully will soon.
So as the interface, it's mostly like Grasshopper 1, and it is just the developed version regarding its core and just fixing some errors and bugs. What's the difference actually?
There's not much to talk about other than if you make a big list of all the things that are wrong with Grasshopper 1, that's most of them meant we had to fix a lot of them. We had to start over on the new the core, and so there's a huge amount of back-end rewrite that once it's out, yes, those problems will go away, but at first people won't see or think it's kind of like, well, why did it take you so long, to do this? It still basically does the same thing. But I mean, there's obviously obvious things like, it's really hard to multi-thread things in Rhino or in Grasshopper and things like that, just basically you've got to rewrite every piece of the software in order for it to work properly.
So what about the older plugins? Do they need to upgrade themselves to meet the requirements of Grasshopper 2, or can they still work on Grasshopper 1 or maybe together?
Well, the big work is there. The interface, of course, will get refreshed. And part of that is being done because a lot of that interface work was sort of handwritten and pixel by pixel. So part of it is rewriting it so that stuff can be generated without everybody having to figure out what every pixel's going to look like to add a component to it. I mean, it's not quite that bad, but as you can imagine, it was pretty tedious in the early versions. And then, of course, there'll be lots of new components as you try to handle things that we couldn't do before.
Yeah, and is David still working on the Grasshopper 2? And he's also from Rhino team as well, right? And then you developed the idea of starting this visual scripting in Grasshopper together.
We're not really sure yet how much work we're going to do to make absolutely sure it's compatible. There's a couple of scenarios that we're looking at. There's one example of something that might work just fine is to be able to have both of them running at the same time. And it might be easier just to have them talk to each other than it is to actually have one run, the old stuff run inside the new one. But that might be just a trick that we're doing on the back end that the user doesn't see, or if they do it won't be painful. But that's an example that may not work out.
Normally, architects don't like to work with those boring pages or black pages with coding lines. I call it boring. That's how architects see it, but I don't see it as boring. And I know how to work with Rhino, Grasshopper, and I know how to code in Python and also in website. But generally, architects are soft and they want everything which is beautiful, and they want to deal with the beauty, with the colors, with everything related to the beauty. They don't want to deal with these kind of codes, with these kind of numbers, algorithms, or anything like that. But I mean, I'm an architect. I worked as an architect for 10 years, and I know what they want. I know how they think. I know what they like, and I know what they don't like. And this coding stuff, at first, it seems they don't like. Mostly they say, it's not my type, it's not my work. But when they start working first as in Rhino and then in Grasshopper, when they start working and they see the results, they fall in love with the capabilities it brings, with the things that software enables them to do. This makes a lot of difference regarding if the software is, and this makes a lot of a difference when architects try to do it themselves. And when they start using it, they see its capabilities, how it can make a difference, and how fast they can do the process and all these things. They fall in love with it. The same thing happened to me as well around 2014 and 15, and when I learned the software, I understood its capabilities, what software can allow me to do, and everything started changing. And first of all, my entire career changed. We ended up building and establishing this platform, and then everything just continued. Yeah, and to continue and talk about the Rhino and Grasshopper, we know that these software have made a significant impact on the different industries regarding the design and the process in the recent years. For instance, in architecture, industrial design, interior and product design. The capabilities of this software are exponential, and using the power of computational and parametric design, architects and designers have created outstanding projects. Was this something you had foreseen this coming, or you think it was not pre-planned and you wouldn't think it in this way?
Again, it goes back to our idea that, the core of it is focused on freeform shape, right? And then from there, you kind of add on the fact that we don't know enough about all the disciplines where freeform shape is critical. And so then you add the tools to extend the software. Then it becomes a question of, well, what does each of the industries need, right? And because we're not experts in it, we just want to make it easier and easier for people to do whatever it is they want to do. And of course, you guys are the creative ones here. We're not. I mean, we're just throwing the tools out there, and if it's painful, it seems like people complain, and then we try to figure out how to make it less painful. And sort of going back to the question, did we have a clue that this was the direction it was going? We got some early clues, but we sort of ignored them. One of the first week that we shipped Rhino, somebody from Frank Gehry's office ordered a copy of Rhino. At that point, most of the people in the office didn't know who Frank Gehry was. So we just assumed that our limited knowledge of architecture assumed that we had saturated that market of freeform architecture with the sale of one copy. There was no reason to pay attention to architecture beyond that. And we ignored it for a while, maybe for 3 or 4 years. But we did notice that there were a few schools buying it. We saw GSD, the Harvard Graduate School. Yale had ordered a few copies. The students we could see were ordering copies once in a while. It was like, yeah, kids playing around, keep them entertained. They'll be lucky if they can get a job.
And regarding these feedbacks and comments, the developers team was trying to solve the issues and provide the tools as much as they can.
Later we found out that there were architects or professors really were playing around with these ideas, and you probably know Mark Berry. I really first kind of got the idea that this might be useful when the first time I met Mark in, I don't know what year it was, but I happened to be in LA, and I had stopped by Gary's office, and he was there doing a talk, and we had lunch, and he was going on and on about how he needed better scripting tools and all this. The example he was, of course he was a professor at the time, but he was also working on the Sagrada Familia project, was sort of the lead geometry guru on that project. So he was using that as an example of, if you just have better scripting tools, then, we could generate these things. We know what the math is for these shapes, but right now we still have to figure out how to do this by hand. So anyway, that was kind of my first clue that there was some usefulness in the AEC industry for more scripting tools. And that was probably well before we had anything working really at all. And, again, you look around and you see something like the Sagrada Familia, it's like, okay, I'm going to take a team of developers and have them work on something for one unique project in the world. I don't think so. I'll go broke fast listening to Mark. But that was sort of the first clue. And then, by the time 4 or 5 years later, you start seeing some stuff show up, right? Whether it's from Zahad's office or Moshe Softy's, some of their early projects, and a lot of stuff was happening in Europe by then, and the engineering firms and stuff. So, and then people would start sending us problems. They'd say, well, this all worked, except how come I can't do this? And here it is, the big chunk of the bird's nest in Beijing, and it's like, I don't know why that doesn't work. You shouldn't be using Rhino for that. That's foolish. Buy Katia or something. Leave us alone. But eventually we started paying attention and doing what people needed. Yeah, when you get into the shoe industry, for example, they have, or something like automotive they had their own development teams writing software on top of Rhino. And so that often their development team was bigger than ours. So those moved along fairly fast because those teams were embedded in the process. They understood all of the issues. And of course, there were other add-on products that were used. And we just had to work on being compatible and making sure the development tools and core geometry worked. But then there were other industries where there wasn't dominated by big players like the marine space, but there were specialty marine software products out there. And some of those companies, a few of those companies just moved their core project and product, which was standalone, to be built into and on top of Rhino. And the same happened in the jewelry industry as well. So, the jewelry industry itself wasn't really a focus of ours, that we were kind of dragged into that because some other developers in that space wanted to use the Rhino core as their foundation for their product. And I think now most all of the dominant products in the jewelry industry are built on top of Rhino. They may not be branded as Rhino. You may never see even the interface of Rhino in some of the applications.
Yeah, I've seen Matrix. Is it one of those softwares?
Yeah, Matrix is probably the dominant player in the U.S. Yeah, there's a variety of them around the world.
Yeah, discussing the solving of designers and issues, and also answering these feedbacks and comments. One of the issues was connecting of Rhino and Grasshopper with other software such as Revit, Dynamo. Designers were using a lot of other plugins and third-party formats to connect these software together. The company has recently released RhinoInside, which gives the ability to connect with other software. It could be Illustrator, Adobe, it could be Autodesk, Revit, and Dynamo. Can you discuss how this need was emerged as an idea and how the company worked on to develop this idea?
Well, it actually started more as a extension of our development tools. We're finding a lot of people wanted to use parts of Rhino. They didn't really, like I mentioned, a lot of times you don't even see the Rhino UI. So with Rhino 7, what we did is we essentially divided the product so that the interface layer and the geometry core are sort of separated enough. So from a technical point of view, Rhino itself, all of it now is, I guess in the Windows world, you'd think of it as a DLL. It runs inside a very thin application called Rhino. So there's this big thing that's separate from the actual Rhino itself. And the idea was that then you could connect to it, as a user product, or some of the earliest use cases we had is we embedded it in a web browser or a web server, so that somebody could write a web application that actually talked to this server, which was actually Rhino. And so that was sort of the foundation, and then from there it just made it possible to say, well, where else is this needed? And we prototyped a bunch of examples, one in AutoCAD and Excel and Illustrator, Revit, and it's all open source. So we just threw it out there and said, what do you want to do with that? And other people have picked it up. I'm sure you're aware that, Tekla has a version of it for their product, and, a variety of Graphisoft and all of the other, and they picked it up and did it on their own, and of course with support from us and adding things that they needed or asked for. The Autodesk product, because they had their own tools, Dynamo in this space, they had no interest in it. Really liked to keep their user community inside their own bubble, which from a business point of view makes a lot of sense.
Yeah, because Revit is not that much open source if you want to compare it to Rhino. It is maybe, but it's not like Rhino Grasshopper, and not everyone can write the plugin or any code for that. Is that right?
Yeah, I mean, it is in a sense, but in another sense, it's not designed to pull in third parties. Yes, it supports them, but,
Yeah, generally, but normal designers cannot write any plugin or work with its open source, right?
yeah, they can, but it's not easy. It's not a focus of theirs. And so, our sort of wandering around making examples for people. We thought, well, Revit's going to be one that somebody's going to want to do. And so, we prototyped that and threw the source code out there. And, we got a lot of interest in it, but it was similar to, in the AEC space, is similar to what happened with Grasshopper. Everybody liked the idea, but didn't really like the idea of typing code. So we just sort of moved that one ahead on our own, and hence, it just kind of went, okay, we gotta support this. So we pulled in some people, got a couple of people on staff that actually know Revit now, which we didn't know when we built the first prototype. It was like, we have no idea how people get this damn thing to work. But we did know that it was, an important tool in the tool chain, right? I mean, you've got to deliver drawings out the other end, and it appears to be the most commonly used drafting product out there, or tool for generating drawings. And so, it was like, okay, we got to figure out how to make this work better, get rid of as much of the pain as possible.
And was there any collaboration between Rhino with other software companies, for example, Adobe or Autodesk, to tackle with this issue and provide as much as they can? Or was it just Rhino working on RhinoInside?
Yeah, I mean, it was, when you develop developer tools, one of the things you've got to do is test them a little bit. So, building prototypes in these other ones was kind of, okay, how do you connect this to whatever, right? And because that's sort of the first example, sort of the hello world example that you need to provide developers so they get an idea where to start. And so we just used the public SDKs that were available from Adobe and Autodesk and anybody else, Microsoft. We didn't really go to them for help beyond what they normally provide publicly. And it's worked out. I mean, it's worked out fine. It's just that we did learn that Adobe's SDKs were painful, maybe possible. I mean, because, they're cross-platform and they've sort of got their own development infrastructure, which is not really standard Windows stuff. And, what else did we try? I guess SketchUp, we just kind of ran into some dead ends there, so I don't think we even have a prototype there. But, it's really depends on the development infrastructure that's provided on the operating system level. And you'll notice there's not a Mac version of it. We had just technically haven't figured out how to do it in their, using their development platform. I mean, it's probably possible, we just haven't spent the time on it.
Yeah, we talked about Grasshopper too, and also RhinoInside. And are there any other products or any new feature that we should be expecting to be released near soon?
I mean, like I mentioned early on, we're driven primarily by what seems to be painful for people. I guess if we look at the Rhino 8 list, I think there's something like 3,500 items on it, things that people have asked for. But that said, there's always some core work that needs to be done. And a lot of that stems from the changing world out there, the hardware platforms that are commonly used, or the infrastructure. So the one thing, for example, that's going to take a bit of time with Rhino 8 is robust support of the new Mac world. There's both, the new processors, right now we're running, we run on those behind their simulator, which is pretty good. It's not a step backwards, but it looks like it could be a dramatic step forwards if we run natively on the silicon processor. And then there's also the display pipeline. You know, they have their own graphics chips built, or GPU built into their own processors now, instead of using the, you know, brand name ones out there. And it appears that if we can take advantage of that too, there's a huge performance. And both of those are tedious and not real obvious in terms of, hey, this is the best thing. But it does require, you know, going back and looking at the whole Rhino code set and making sure there's not something that won't work. Because we run off of this, we only have one code base now, so that gets compiled either for the Mac or Windows. And so that's making those kinds of changes. We've got a lot of testing to do on both platforms to make sure we didn't break something. So those are the types of things that happen in the background that take a lot of time. As far as what the user's gonna see, boy, that's just always an endless list. You know, you kind of try to decide between, okay, how many people does this really help? You know, one of the requests we often get, for example, is, well, if you just do this, I can replace blah, blah, pick your other piece of software, right? I don't need Illustrator any longer. I don't need Photoshop any longer. I don't need, you know, I don't need Revit. That's probably the biggest one. And so we kind of try to filter a lot of that stuff out, although there are some areas where, you know, it's so close that you can say, well, if we just do a little bit more in the area of dimensioning, for example, then there's this market segment that doesn't need it, you know, to transfer this stuff into another application to finish up a few drafting issues, you know. But like I said, the list is endless, and we're always trying to figure out where the balance is, because of course you want to help as many people as possible.
Yeah, right. I'm sure we discussed this one, but what about the long run, and what is the Rhino's destination and the way it's going?
Probably clueless. I mean, it depends on how, you know, the needs evolve out there, I guess. I mean, we've learned a long time ago that we're not smart enough to have a clue, I guess. It's really about paying attention and watching what people need. On one hand, I'd say that, yeah, there's tons of stuff going on out there that everybody's all excited about, you know, new technology for this or that or the other thing. You know, some of it becomes fashionable for a while and then sort of disappears, and then some of it's eventually works its way through until it's useful in some cases.
Yeah, right. Do you have any plans to integrate these 3D printer softwares inside Rhino or Grasshopper? For example, it could be G-code or any software like that to integrate it to Rhino and Grasshopper?
Well, that's a good question. You know, people send us 3D printers and stuff that they're all excited about. We got the first one, was from 3D Systems. They sent it to us before Rhino was released, and wanted to make sure that, you know, we were compatible with it. But it turns out it's not that simple. You know, by the time you add supports, makes adjustments for the types of materials, and all the stuff that go into any digital manufacturing process, somebody's got to be a real expert in that. You can't make assumptions that this is going to work generically for all 3D printers. It's just the technology, the material types are also different the subtle things that you've got to make, adjustments you've got to make, somebody's really got to know what they're doing. We don't have that depth of expertise, nor do we have, a room full of thousands of different machines and the time to play with all the different materials and all that kind of stuff. And I'm not sure it would help that many people.
And what about the other software or other competitors? Do you think, for example, if we can say Houdini is one of the software that nowadays designers are mostly switching into that side rather than using Rhino Grasshopper? I don't know why. Maybe it could be because of its ease of use or its capabilities. What do you think about it? Can it become a competitor, or is Rhino considering to have much more easy interface, or I don't know. What do you think about it?
I don't really know much about Houdini. I mean, I was sort of aware of it maybe 20 years ago. It showed up, a little bit, in the film industry maybe 20 years ago. But, frankly, I didn't realize they were even still in business. That's how long it's been since I've heard that name. I think that's the first time in five or more years that anybody's ever mentioned it to me. So I have no idea what they're doing or what it is. No, usually when somebody wants something, they'll often use another product and say, well, if you would just do something like this, that's how we hear about other products. Or it's, we need to get files from here into this product, or, this model into here, or whatever. And frankly, that's the one I literally haven't heard of in 5 or 10 years. I assume, at that time it was quite expensive. I don't know if it still is or not.
Yeah, I'm not completely sure about the prices, but I've heard it's around $300 for 1 year, which is a little bit pricey, I think. Yeah.
It's kind of like, to me, I guess I would put it in the same category as CATIA. A lot of our even architecture users or customers have or had some CATIA at times, but because of the price of it, it seemed to fade away eventually, unless they're in the automotive industry or aerospace or something like that.
And how many employees does the company have worldwide?
Oh, we're worldwide. We're right around 100 people. Well, compared to Autodesk, 10,000 people, right?
Yeah, right. But they have a lot of products, and they are working on all sides. But compared to Rhino, which is just Rhinoceros, I think Rhino is doing really great.
No, it's never been more. Technically, that I would call that full-time equivalence. I think if you actually look at the list of people with McNeel.com email addresses, probably more like 120, but there's, for example, we have 3 interns in Latin America this summer, and so they're there for the summer. And then, I've got some people that work, that do teacher training for high schools that only work like 3 or 4 weeks every year doing some teacher training, things like that. So I would say maximum, if you gathered all of those people together, there's like 120 of individual names that you could put on that list. But as far as actually showing up on a full-time basis, if you lumped them all together, it'd be right around 100.
Yeah, awesome. Great. Thank you. Thank you so much for this insightful conversation, talking about the company, its history, and where did you start it? And in closing, what kind of advice would you like to share with young professionals?
Well, I'm sort of partial to maintaining a lifestyle that I've become accustomed to. So, a lot of the advice I have has more to do with make choices that'll support the lifestyle that you aspire to. So, but the thing that I've always found that works is if you can find something you like to do and other people need, then you've got potentially a great lifestyle ahead of you. But so many I watch so many people that start with the idea that they're gonna do what they like to do, and then they hope that somebody will pay them for it. You sort of have to reverse that. You have to find something that people need first. And people need all kinds of things, so you can wander around and try all kinds of things until you find one that you really enjoy doing. But start with something people need. Otherwise, you're just going to be a starving artist.
Awesome, great. Thank you, Bob. I really appreciate that. This was a very inspirational conversation for me. I enjoyed it a lot. Thank you so much, and we look forward to having you in the show in the future as well. And thank you. Goodbye.
No, really, it's fun, so I appreciate the time.
Guys, thank you so much for watching this episode. I hope you enjoyed it a lot. We would like to thank you, Shape Diver, for supporting this podcast. So earlier today, I was exploring some of the clients they show on their marketing page, and I was quite impressed by the variety of different industries using Grasshopper. To think it all started with architecture, and now it's extended to furniture, medical services, jewelry, and more. Parametric design and Grasshopper are here to stay. Make sure to visit them at shapediver.com. Learn more and create a free account. Thank you so much for watching this episode. Hope to see you soon again in the future episodes. Goodbye.